Hello students, welcome to Inside Physics. This is Srinivas. Today we will discuss about thermodynamics. Okay? Thermodynamics. What is thermodynamics? See, a branch of science which deals with the concept of heat and the relation of heat with the mechanical work. Okay. So what is the relation between heat and mechanical work? Mechanical work is converted to heat energy and in vice versa. Because of mechanical work, heat is also produced. Thermodynamics deals with this relation. Okay. Based on these observations, thermodynamics laws are developed. So with these laws, actually, heat engine is invented. Heat engine does the mechanical work is into heat energy, and it will convert heat energy into mechanical energy. In this way, heat engine is developed on the basis of thermodynamic laws. Okay. Now we see something about the heat and how the heat was presumed in some olden days. Prior to the concept developing the concept of thermodynamic laws, the heat was presumed to be a invisible fluid flowing from one body to another body. Heat was thought that it could be an invisible fluid like thing. So this fluid, when it is there in the hot body, it is called caloric, and when it is associated with a colder body, it is called frigoric. So this theory based on this movement of something invisible fluid like thing, they have uh, told this theory as caloric theory. Okay, but later the caloric theory is failed to observe the thermodynamic laws, and the development of thermodynamics failed to explain the further development of thermodynamics with the observations of Benjamin Thomson. So what does Benjamin Thomson did was he actually preparing some cannons. Okay. So while doing that, he is drilling a bore with some sharp drill. In that process, so actually with the help of caloric theory, if we assume, because the more sharper the drill, the more heat is produced. That is the presumption of caloric theory. But it was not like that. The more work done with the drill to drill the bore, the more the heat is developed. So they thought that the heat is related with the work done, not on the movement of the invisible fluid. In this way, the caloric theory has failed. Okay, so later some other scientists like Joule, they also said something about these heat concept and the relation between heat and the work done. So they, what they told is the energy that is either gained or lost in a process of work is converted into heat. Okay, so in this way, based on these observation and experimental facts by Joule and other scientists, so these entire concept of heat and the relation between heat and the work, the energy changes in the process of work, entire thing was made into the some thermodynamic laws. Actually, there are two important laws. The first law says the relation between mechanical work and heat energy. So the second law says the energy changes, about the energy changes, how they take place in the process of work. So while the energy is changing, the amount of heat energy produced or lost will also change. Okay, so here actually the thermodynamics is a macro level concept, not a micro level. It deals with the macro concept of the system we take for consideration. That means the pressure, temperature, volume, and mass. So these are the macro level concept. It does not go into the micro level. That means the atomic structure or molecular structure or the chemical bondings. So these are the micro level concept. When we go into deeper into the atom and molecule, we will call them as micro level. So this is only the macro level, and there are some uh, variables which we deal in thermodynamics. By that we can assess the system which is undergoing a heat change, energy loss or energy gain, heat gain or heat loss, and how much work is being done on the system because of the absorption or emission of heat. Okay, so here actually when we say the thermodynamics is a macro level concept. So if you take an example to tell how this is a macro level concept, when a bullet is fired, okay, when a bullet is fired and it is actually traveled and it is stuck in a wooden block, it is stuck in a wooden block. The bullet is stuck in a wooden block and it has pierced into that, and the kinetic energy of the bullet has come to zero when it is stopped and stuck in the wooden block. Okay, that kinetic energy will be transferred to, will be changed to heat energy, and the entire kinetic energy has come to zero, and this kinetic energy will be the cause of the production of heat in the, for the bullet, the temperature rise in the bullet, and some temperature will also be raised surrounding the bullet, because in the wooden block surrounding the bullet also. This temperature change is actually does not depend on kinetic energy. That means the internal temperature, the temperature means it is an internal thing of the object. So if a temperature of the body is raised, that means it is an internal thing, but the kinetic energy is only the cause of raising the temperature. Okay, so in this way we can say that thermodynamics is a macro level concept. Okay, so next we will go to some definitions, some concept level understanding here. Next thing we will understand what is heat and temperature. Heat and temperature. So heat actually is an invisible form of energy. Okay, invisible form of radiation. So in this way, so the heat in the form of invisible energy will be transferred to one object to other depending on the temperature difference. Okay, the temperature difference is the only cause of the heat to travel from one object to another, or the heat will be transferred. Instead of traveling we can say transfer of heat from one object to other because of the only difference of temperature. Okay, so in this way the definition of heat can be said as the energy transfer between the two objects because of the temperature difference only. Okay, this is the definition of heat. Okay, so what is the units of heat? So in SI system, the unit of heat is joule. Okay. So next one. Here we say that because of temperature difference, the heat transfers from one object to the other. So what is temperature? What is temperature? Here the temperature is a condition of the body. This means a condition of the body by which it will emit or transfer the heat to the surroundings, or it may be in a condition to receive the heat energy from the surroundings. So if a body is, we say it is hot, that means the condition of that object is hot in terms of temperature. That means hot in, and the presence of surroundings are not that much hotter than this object. So there is a temperature difference between surroundings and this object. So that means the object is ready to give away some heat energy to the surroundings, so that it becomes into a thermal equilibrium with the surroundings. So any body, if it is hotter, it tries to give away the heat energy. If it is colder to compared to the surroundings, it tries to receive the heat energy from the surroundings. So the condition of the body is called the temperature. The condition means here whether it is in a position to give away the heat energy or receive the heat energy from the surrounding. That is the condition, tells the temperature. Okay. So here we say that the joule is the unit of heat, and another unit of heat is the CGS unit is calorie. Okay. So joule and calorie are the units of heat. What is a calorie? Can we define the calorie? See, calorie is the amount of heat energy required to raise 1 gram of water by a temperature of 1 degree centigrade. This is the definition of calorie. But when we see the water is being heated from 0 degrees to 100 degrees temperature, and we if you take the average of 0 degrees to 100 degrees temperature, and the average value is equal to the heat energy required by the water, heat energy required for the water to raise the temperature from 14.5 degrees to 15.5 degrees centigrade. So actually, in this way, if you take the mean average of the heat energy while boiling the water from 0 degrees to 100 degrees centigrade, and if you take the, if you want to calculate the average heat energy required to raise 1 gram of water by 1 degree centigrade, so that average will be equal to the average heat. See, the heat required for to raise the 1 gram of water from 14.5 degrees to 15.5 degrees centigrade at 1 atmospheric pressure. So in this way, we can define the calorie as the amount of heat energy required to raise the temperature of 1 gram of water from 14.5 degrees to 15.5 degrees centigrade at an atmospheric pressure of 1 atmosphere. Okay. So this is the definition of calorie. So we have now understood something about heat, temperature, and what is that thermodynamics is all about, and what actually the thermodynamic laws say and how they are developed. Now we see next what is thermodynamic thermodynamic system. What is thermodynamic system? See, if you want to get some idea about some object, how it behaves with absorption or emission of heat, how it how the heat energy transfer is taking place, and how it responds to the heat, and how the work is being done on the system. These all facts, to study these all facts, we need a system for that. The system is actually called a thermodynamic system. The system may be a space, a small space with a definite or indefinite boundary in a space containing a number of atoms or molecules. This may be also called as a system. So the system now is being studied by the observer. So how it is responding to the heat absorption or emission, how the work is being done on the system because of the heat energy supplied. So how the thermodynamics laws are adaptable to the system. So these things will be studied when we consider a system and we observe the process that when we apply the thermodynamics laws. Okay. So in thermodynamic system, actually we have some variables to observe what is going on. So what are variables? Variables means a macro level variables which are being changed in the process of heat transfer. So these thermodynamic variables, okay, that is pressure, volume, temperature, mass, internal energy, entropy. Pressure, volume, temperature, mass, internal energy, and entropy are the thermodynamic variables which we observe in a process of thermodynamic process and in a process of heat transfer. So how the system is undergoing the changes in terms of these six variables. Okay, so we have now understood the what is thermodynamic system. So the types of thermodynamic systems actually, what are they? First, we consider what is a closed system. Closed system. What is a closed system? Closed system means it doesn't mean that it is closed by all means. So, if a system is allowing to exchange the energy, the heat energy or thermal energy in the process, and it does not allow any exchange of matter, is called a closed system. A closed system only allows thermal energy but not any matter. Okay, matter means the internal matter of the system. Okay, so can we have some examples of a closed system? Can we have some example of a closed system? Okay, when we take um, an object, see, with some movable piston, with some movable piston and some gas is contained in this container. The container is having a movable piston, and this container with and the movable piston are all a good conductors of heat. Okay, so this can be considered as a closed system. That means if you consider any gas inside the piston, inside the container, and we if you move the piston and up and down, so if you move in, the gas will be pressurized and the volume will decrease, then the heat energy will increase. And if you move the piston backward, the gas energy will be, the gas will be expanded and it loses some heat energy. So in this way only heat energy is allowed to pass to transfer through this entire system, and the no matter is exchanged here. So inside that the gas is will stay like that, and no matter is no matter is exchanged with the surroundings. This is one of the example of a closed system. Okay, now next, what is open system? What is open system? So a system which allows the transfer of energy and matter also, both energy, heat energy and matter. So a system which allows the exchange of both heat energy and matter, both heat energy and matter. So here, by undergoing the heat energy transfers, and the temperature may increase or decrease of the system, and in this process the matter of the system is also being exchanged with the surroundings. So we see one example for that. What is a open system? See, an open bowl containing some water in it. When the open bowl containing some water in it is heated to up to a temperature, heated up to a temperature, then this water being getting the increasing the temperature of it internally by receiving the heat. When we heat this one with some burner or something, so this water will be taking heat from the external source, and the internal energy is increased, and it will be getting slowly evaporated, right? That means the work is done against the molecular attractions of water molecules, and this water will be slowly being evaporated, and this matter is exchanged with the surroundings. The water vapor will be exchanged with the surroundings. So this is an example for open system. Okay, so next one, the third one is closed system. What is it? We are talking about the thermodynamic systems actually, by considering the exchange of heat, matter and other things, how they behave in the process of heat energy receiving and giving. Okay, so the third one is isolated system. Isolated system. So what is an isolated system? A system which neither allows the exchange of heat nor it allows the exchange of matter. That is completely isolated, and it doesn't permit either heat energy or matter. So this is called isolated system. So in these systems generally doesn't participate in any kind of reactions or in any kind of processes generally. So one example is for isolated system is our universe. So universe actually has internal matter, it has a lot of a matter, and has its temperature of variations inside our universe it will be happening a lot. But actually, as the scientists found out, the energy, heat energy is neither permitted to leave the universe, or the universe will be taking back the heat energy. Neither of it will happen. And the matter also, our universe will not exchange the matter with any of the surroundings. So, okay. The second example of the isolated system is the thermos flask. Thermos flask. So thermos flask actually, if you it is a container to prevent the objects stored in it to either to give the heat energy, or they will not accept any heat energy from the surroundings. So the temperature of the body inside the thermoflask or any object or any liquid inside thermoflask will be having same temperature for a long time, because it does not allow the heat energy to transfer to the surroundings, and it will not be taking the heat from the surrounding. It is an isolated system. So that the making of thermos flask is a different concept. It has some vacuum between the two layers of that metal outside sides of the thermos flask. So that vacuum does not allow the temperature, the heat energy to flow between the matter and between the system and the surroundings. So in this way, an isolated system and a closed system and open system. So these are the classification of thermodynamic systems into three types. So this is the brief introduction and the concept of temperature, heat, and thermodynamic systems and variables. So in further classes, we move to some thermodynamic laws and we will go to some problematic information. We will do some problems on thermodynamics. That's all for today class.